Once again, welcome to 4Keys Private Tuition. I'm your host, Sei Shungu. In this particular video, we're going to be talking about Chatelier's principle. Chatelier's principle. So it's about systems that are in equilibrium. So if you know reversible reactions attain equilibrium when the rate of the forward reaction is equal to the rate of the backward reaction. So the equilibrium can shift in terms of the amount that is available. You can have more of the product or you can have more of the reactant depending on the position of the equilibrium. So when your equilibrium shifts to the right as shown there, we are going to have more of the product, and when it shifts to the left, we are going to have more of the reactants. So it's important to remember these terms. When it shifts to the left there, you have more of reactants. When it shifts to the right, you have more of the product. When it's in the middle, then we assume that we have equal concentrations for the product and the reactants. So let's move on. So this is in response to change in conditions. So basically, Chatellier's principle says changing the conditions of a reversible reaction will affect the position of the equilibrium. So the equilibrium will shift in such a way to try and minimize or counteract the change. So if you change conditions, then your equilibrium is going to shift to try and minimize or counteract that change. So let's look at examples here. Let's suppose here you have a reaction between nitrogen and nitrogen to produce ammonia in a sealed container. Then you know that the forward reaction is exothermic. My enthalpy change there is negative, showing that the forward reaction is exothermic, and the backward reaction is endothermic. So if I decreased my temperature under these conditions, if I decreased my temperature, then the equilibrium is going to shift to try and increase the temperature. Then it's going to move in the forward direction, which produces more ammonia and fewer of the reactants. So I'm going to have fewer of the reactants and more of the ammonia because I have decreased my temperature, and the equilibrium is trying to minimize that change. So it will minimize that change by trying to increase the temperature, and to do so it has to go in the direction that will produce heat, which is the exothermic direction or the forward reaction. So if I did the reverse, if I increased temperature, then my equilibrium is going to try and minimize that temperature increase, and to do so it has to go in the direction that consumes heat, which is the endothermic reaction. It's going to take away the heat and hence reduce the temperature in the process, and in which case I'm going to get more of the nitrogen and hydrogen and less of the ammonia. So this is important to remember. Okay, how about pressure? So pressure, if you check my previous video, it's about how many particles are there per given volume. So the Chatellier's principle is also going to work here. So if you look, if I add the total number of particles or the molar ratios according to my equation there, I have 1 mole of ammonia plus 3 moles of hydrogen per given time. So I have a total of 4 moles to my left, and these will produce for me the 2 moles of ammonia. So that means I have more moles to my left and fewer moles to my right. So the pressure, when you decrease the pressure, the reaction is going to try and increase the pressure, which is to minimize that decrease. So in doing so, it's going to go in the direction that will produce more particles. So if I decrease my pressure, the reaction will go in that direction to try and increase the pressure. So that means I will have fewer of the ammonia and more of the nitrogen and hydrogen. So the reverse is true. If I increased here my pressure, if I increase my pressure, okay, let's look at what would happen. If I increase my pressure, then the system is going to try and minimize that decrease that increase in pressure, and it will try to decrease, and to do so it has to go in the direction with fewer moles, so it will promote the forward reaction. So we can see from what we've done so far that you can manipulate the conditions of temperature and pressure to maximize your production of ammonia. So you just need to think which conditions are going to promote the forward reaction. Okay, let's move on to something else. So here, if I tempered with concentration and I increased the concentration of my nitrogen, remember pressure and concentration work in a similar way, so I will have more particles to my left, and the system will try and minimize that, and it will shift to the right to try and decrease the number of moles. So this is how the Chatelier principle operates in the Haber process.